The title of my presentation is Investigation of Fatigue Damage Accumulation by Measurement of Deformation Response to Narrow Notch Increment. This presentation was prepared together with my colleagues, Dr. Pisarev and Mr. Eleonsky. Outline of presentation. First of all, I'll give a brief motivation of present research. After that, we will consider experimental procedure. To analyze the effect of low cycle fatigue damage on fracture mechanics parameter. Of course, we will introduce into consideration fatigue damage accumulation analysis. And finally, conclusions. So, motivation of present research. Cracks in aircraft structures. Random overloads with negative stress ratio, which are inherent in aircraft structures operation, and high level of maximum stress can contribute in the acceleration of damage accumulation process. Moreover, stress concentration inherent in individual elements of pin or rivet joints is the main reason of arising local elastic plastic strain under real operation conditions of aircraft structures. So, this damage process can eventually leads to substantial reduction of residual life and strength due to low cycle fatigue influence. So, goal of present research is to analyze the effect of damage accumulation in the vicinity of hole due to preliminary low cycle fatigue loading on fracture mechanics parameter. After preliminary low cycle fatigue loading, consecutive narrow notches emanating from the hole are performed under the constant external load for each specimen to estimate the effect of damage accumulation on fracture mechanics parameters. A measurement of deformation response caused by local material removing in the form of a notch is carried out by electronic speckle pattern interferometry. Experimental procedure. All tests were carried out on flat specimens with a central open hole of diameter 3 mm. Material of specimens is aluminum alloy with yield stress 330 MPa. Absence of residual stresses in all specimens is established by combining the hole drilling method and electron speckle interferometry measurement. Experimental procedures include the following step. One specimen, which is common for all groups, is tested before low cycle fatigue loading. Other specimens are subjected to low cycle fatigue under uniaxial push-pull loading with the parameter presented in this table. After preliminary low cycle fatigue loading, consecutive narrow notch emanating from the hole are performed under the constant external load. For each specimen, all experimentally obtained parameters correspond to constant remote tensile stress 53 MPa. Step-by-step procedure of increasing notch length is performed by narrow saw of width 0.017 mm. The effect of low cycle fatigue damage on fracture mechanics parameters. Initial experimental information is obtained in terms of in-plane displacement components. Some examples of interference fringe patterns are given in these pictures for various stages of low cycle fatigue. This slide gives a scheme of consecutive narrow notch emanating from the hole. A measurement of deformation response caused by local material removing in the form of a notch is carried out by electronic speckle interferometry. Dependencies of crack mouth opening displacements against number of cycles. Values of crack mouth opening displacements show considerable influence of aluminum alloy hardening due to high level of plastic deformation in the vicinity of the hole for stress ratio minus 0.33. Dependencies of stress intensity factor against number of cycles. It can be seen very close form for difference value of stress ratio at the initial stage of low cycle fatigue. Dependencies of T-stress against number of cycles. Very close form for difference value of stress ratio, again at the initial stage of low cycle fatigue. Damage accumulation analysis. The evolution of normalized values of stress intensity factor for first notch increment employed as a damage parameter, which relates to the first notch coming from the central hole in specimen. The correctness of displaying the process of damage accumulation follows from the equality of areas under diagrams of normalized stress intensity factor against durability of specimens. Here, Nm is number of preliminary cycles of fatigue, and F corresponds to the fracture of specimens. Fatigue damage accumulation rate is presented as a function of number of cycles and stress intensity factor, which is function of stress ratio, stress range, and number of cycles. So, damage accumulation function can be given by the second equation. Boundary values of damage accumulation function can be written as follows. Damage function is equal 0 in the case without fatigue loading, and this parameter is equal to unit in the case of failure under fatigue loading. These slides present the effect of stress ratio on damage accumulation function. I'd like to pay your attention on the following. The experimental curves contain measurement points that correspond to damage function 0.84, 0.89, and 0.87 of accumulated damage for various range stress ratio. Up to these points, damage accumulation occurs accordingly to linear law, regardless of magnitude. The starting point of the nonlinear cross-sections is identical for all three investigated values. It can be assumed that this stage of damage accumulation process corresponds to the formation of macro defects with the subsequent origin of crack and its further spread. This slide presents the effect of stress range on damage accumulation function. These dependencies show that the effect of stress range on the damage accumulation function differs quite markedly from the influence of the stress ratio. Indeed, the linear nature of the accumulation function is violated at the point number of cycles 5350 cycles. And conclusions of my presentation. The following conclusion can be drawn. The effect of damage accumulation due to preliminary low side fatigue on fracture mechanics parameters is experimentally analyzed by combinations of crack compliance method and electronic speckle pattern interferometry. Deformation response to small notch length increment, which is made under constant external load, serves as an indicator of damage accumulation at different stages of low side fatigue. The description of fatigue damage accumulation is analyzed by means of proposed damage accumulation function. The effect of stress ratio and stress range can be described by the damage accumulation function. Thank you for your attention.